Hello, algebra students. Mr. Lawrence here, and we're going to solve systems of linear inequalities. After yesterday, you should see how simple it is to graph linear inequalities. Well, we're going to have a system of them, which means we're going to have two. And, in a system of linear equations, we're looking for the place where the two lines cross, right? Well, in this case, because there's shading, we're going to look for where the shading overlaps, okay? And this will be really cool. And hey, by the way, you do know what yellow and blue make, right? A really bad day. Oh, sorry for you fans of the state up north. No, yellow and blue make green, okay? And so watch what's going to happen with my shading, all right? Let's go ahead and get right down to it. I've got a system here. It looks like they're written in standard form. So I can tell right off the bat that my x-intercept and my y-intercept are both 7 in this particular problem, right? So I'm going to go to x-intercept of 987 right there, and a y-intercept of 7 right there, 987. Yeah, I got that right. And now I'm going to draw my line. It looks like it's going to be what kind of line? What's that, Jordan? Yes, it's a broken line because it's not equal to, there we go. Let's do that. And okay, I'm not going to make it yellow. I'm going to leave it black because of the shading involved. It might get a little hard to see if I leave it yellow um, or change it to yellow. Now I'm going to do my test point. So I'm going to plug in the origin. I am allowed to plug in the origin. So I'm going to get 0 plus 0 greater than 7. Is that true? That is false, ladies and gentlemen. False, I tell you. So I will shade everything over here. Ooh, I don't know if I like that color. Yikes! What was that? Here, let me change it to a more traditional yellow. Maybe. Just move those out of the way and get a more traditional yellow. I didn't write in a traditional yellow because I was afraid that you wouldn't be able to see it. Okay, so there we go. All right, so we're talking about everything from the line to the right, but not including the stuff on the line. It's hard with the airliner to be precise, but I think you get the idea. The line is not included in the shading. Okay, let's see here. Let's see if I can clean that up just a smidgen. Oh, I'm cleaning it up too much. Okay. All right, there we go. So, good. Okay, now we'll do the blue one. And it looks like the x-intercept is going to be 9. The y-intercept is going to be 3. 1, 2, 3, right? Okay, it is also a broken line because it's not equal to. And I'm going to leave it black as well. Make sure there's arrowheads on both sides. All right, make it a little bit thinner. And now I'll do my test point. And I can use the origin. I'll plug in 0 plus 3 times 0. Is that less than 9? Watch your ears. So I am going to highlight the test point. The test point was the origin, right? And so I got a true statement. So my highlighting is going to go from the line down. And look at that. Remember we were talking about yellow and blue making green? Okay, now this is all part of the solution for the second line. But the important area is right here. Let me show you right in here. This is where all the solutions are going to be, not just this little part right here. It goes forever, this little green area. Let me get a green highlighter going here. Um, there we go. So it's going to be everything. And as these lines go on forever, this green region is going to go on forever. And as these lines are moving farther away from each other, the green region will get larger and larger. There's going to be an infinite number of solutions here. All right, see how simple that is? All right, let's try this one. Here I have, oops, um, sorry, it's written in slope-intercept form. Y-intercept is 1, and it's a slope of -1/2, right? Okay, it's going to be a solid line because it's equal to, and let me do this. Hold on a second, there's somebody knocking at the door. They probably want Daddy to answer it. Give me 1 second, I'll be right back. Okay, I'm back. I let my son in, and now I have to do my shading. But before I can shade, I need to use a test point. I can use the origin because the line does not go through it. So if I plug in 0 is less than or equal to -1/2 times 0 plus 1, I simplify that to get 0 is less than or equal to 1, which is a true statement. Okay, so here we go. I'm going to do some shading, and I'm going to shade beneath the line. Okay, and this is when I made mention some of you might want to use highlighters. This is why, because you can get them to change colors. Just make sure you shade properly. Okay, so we're going to be shading all down here. And of course, this region goes forever, everywhere under the line. Now I'm going to graph the other line. And it looks like the y-intercept is 3. 1, 2, 3 right there. And the slope is 1/1, so it's going this way. And it also, this is a broken line, so it's going to do something like this, right? And let me make that guy a little bit thinner there. Okay, he's thinner. And I'll change his color to black. And now I will use a test point. I can use the origin. And I'll get 0 is greater than 3, which is not a true statement. So when I shade for this one, I will not shade the side of the line that the origin is on. So I will start shading over here. Oops. And there we go. And so you can tell that the shaded region is going to be this triangular thing going on like this. Everything over here. Okay, that's it for the video. It's pretty easy stuff. Okay, please do me a favor, disregard this little bit of green that ended up in there. That's a mistake. But the shaded, all the solutions lie from here. They include these on the points on this line. They do not include the points on that line. We're just graphing linear equations. All right, that's it. Mr. Lawrence signing off. Have a good night, everybody.